Hello and welcome to today's class. For today's class, we'll be looking at the solution to the experiment 2 of chemistry practical manual. For this one here, we're talking about density. And let's start with the first one here. For the first one, we have to look for the density of solids. All right. The What we have here is this: place a 50 milliliter graduated cylinder containing 25 milliliter of water on a pan balance and weigh it. Add 20 gram to 30 gram of granulated lead or zinc and weigh again. Calculate the density of the metal. Repeat each weighing 3 times for accuracy. Okay, so when I weighed the first time, I had 142.72. When I weighed the second time, I had 142.80. And when I weighed the third time, I had 142.70. All right, so I have this. So we have to find the mean. All right. Let me stress something, please. If you did not get these values, please do not change your own values. All right. This should just be a guidance on how this is done. Please do not change your values. Just work with your values. All right. For me, these are the values I got. So I'm asked to find the mean. So how do I find the mean? Of course, to get the mean, I'll simply add 1, 2, 3 and divide by 3. So to get the mean, all I simply need to do is this. Come to this. My first value here is 142.72. So for me to get the mean, I'll have 142.72 plus, I'll add the second one there. What I have here is 142.80. So plus 142.80 plus the final one there. My third reading is 142.70. So plus 142.70. All right. So I'll add all of this. And since I took 3 readings, I'll have to divide it by the number of readings I took, which was 3. So divide this by 3. So all over 3. And that's equal to, so I'll get my calculator and try to punch this. All right, so from what I have, I have 142.72 plus 142.80 plus 142.70 divided by 3, and that's about 142.74. So I have 142.74 as my result. All right, so this is my result. So I simply come to the mean there and write 142.74. So my mean is 142.74. I have this. All right, so this is how you fill up the first one here. So come to results. Results said volume of water is about 50.00 milliliter. Please, as I said, if you do not have the same values, please work with your values. You don't have to change your own values, all right? Just use this as a guidance to do yours. All right, so volume of water is about 50.00 milliliter. The weight of water plus cylinder plus lead give about 153.70 gram. The weight of water plus cylinder is equal to 133.10 gram. And the weight of lead or zinc, depending on which of them you used, is about 20.40 gram. Then the volume of water plus lead is about 58.60 milliliter. So if you check in your manual, this point, they made a mistake here. They wrote gram, all right? But then volume is not measured in gram. So you can correct this. So check your manual. I think this should be in gram instead, all right? So correct the gram. Correct this from gram to milliliter. So correct this point on your manual. Change the gram there to ml. That's milliliter. So I have this. All right, so yeah, so this one here, we have to find the density of lead or zinc observed. All right, so we have to find density of lead. How do you find density? Now recall that density, this is density. Density, the symbol for density is rho. This is called rho. Let me write it out there. R-O-H-O. That's the symbol for density. It's rho. It's pronounced rho. And my formula is equal to, density is equal to mass all over volume. So if I want to get density, I'll simply have to divide mass by volume. All right. So question now is, what's the mass? We have to find the density of lead or zinc observed. So we have to find the mass of lead and then find the volume of lead, right? So how do we get that? What do we have here? All right. First things first, if you look at my work here, observe that the weight is measured in gram, not kilogram, not Newton. Now, normally, if you're doing physics, weight is measured in Newton, not gram. So, seeing gram here means what you have here is actually a mass, not a weight. All right. So, this is chemistry, not physics. In physics, you have to convert weight from gram to perhaps Newton, right? But for this one here, they give us the weight of lead as 20.40 gram. For the fact that this is gram, it means it's actually mass. So they are using mass and weight interchangeably in this question. So hence, I can see that the weight or perhaps the mass of lead is equal to 20.40 gram. So that's equal to, my mass becomes equal to 20.40 gram divided by, let's get the volume. So how do you get the volume of lead? How do you get volume of lead or zinc? How do you get that? Now, if I look at this point, look at E. E here, we have volume of water plus lead. If I look at A here we have volume of water. So in E here, we have a combination of the volume of lead and water. And then in A, I have a combination of the volume of water. So how do I get volume of lead? That will be easy. I'll have to subtract E, which is the combination of volume of lead and water, subtract this, or perhaps we have to subtract volume of water alone from the combination of water and lead. So I'm saying to get volume, what you do is very simple. It becomes, your formula becomes, so the volume of lead, let me write it here. The volume of lead will be equal to this E here, volume of lead plus water, this value here, that's 58.60 minus the volume of water alone. So it's more like saying I'm having a combination of water and lead and I'm taking out water. If I take out water, obviously I'll be left with the volume of lead. So that's the concept. So it becomes minus volume of water, which is about 50.00. All right. If I subtract this, I should have about 8.60 as my answer. So this should be in milliliter, right? So of course it becomes milliliter. All right, so I have that value. So my answer is 8.60 milliliter. So divide this by 8.60 milliliter, and that's equal to, so let me use my calculator. I have 20.40 divided by 8.60. What do I have there? That's about 2.37 in two decimal places, gram per milliliter. So I have 2.37 as my answer. So hence the density of lead or zinc observed is 2.37. That's 2.37 gram per milliliter. So I have this value. All right, so this is the first part of my work on getting the density of a solid. Let's look at the second part, which is to get the density of a liquid. All right, so let's look at the second part, liquid. Let's see how to find the density of a liquid. In this case, the density of water. Now this one says weigh a beaker and add about 50 milliliter of water measured with a graduated measuring cylinder. Weigh the beaker plus water, repeat two times and record your values. All right, so results, I have my first weighing, my second weighing, and I'm to get the mean. All right. All right, so I have all of these values here. I am stressing again, please. If your values are not exactly this one, do not alter your values, okay? Use your values, but just follow the same process as I'm doing in mine here. All right, so my task now be find the mean of each of this. So the first one, there is mass of beaker plus water, and I have my first weighing and second weighing. I'll just add them up and divide by 2. Since I have 2 weighing, I'll divide by 2 and get my mean. So for the first one, I have 131. So I have about 131.34 plus 131.22 0.22 divided by 2. So I'll divide this by 2, and that's equal to, what's my value here? So that becomes 131.34 plus 131.22 divided by 2. I have about 131.28. So 131.28 is my answer. So my mean here becomes 131.28. I'm maintaining the same two decimal places. All right, let me take this off so I can do for the second one there. All right, the next one here is the mass of beaker. So I have my first weighing and my second weighing. So I'll just add the first weighing and second weighing and divide by 2. My first weighing, there's about 81.16 plus my second weighing is about 81.19. I'll divide this by 2. All right, so dividing by 2, what do I have there? Divide this by 2. And that's equal to 81.16 plus 81.19 divided by 2. I have about 81 points. That's approximately 81.18 in two decimal places. So I have 81.18 in two decimal places. All right, so I'll do the same thing to find my third one. So back to this, my third one, I have the mass of water. So let's get mass of water. I have my first weighing for mass of water as 50.14 and my second weighing as 50.00. Right, so let's get this. So it becomes 50.14 plus 50.00. I'll divide it by 2. So divided by 2, and that's equal to, what do I have there? So I'm punching my calculator. That gives me 50.14 plus 50.00 divided by 2. That's about 50.07. So I have 50.07 as my answer. So this becomes 50.07. All right, we have one final one. That's the last one there, the fourth one there. The last one here, I have the density of water. So I had this as 0.49, 0.48, 0.9832, and then 0.9802. So I weighed this the first and second time. Let me get the mean. So that would be about 0.9832 plus 0.9802 all divided by 2. So I'll divide this by 2. So divided by 2, what do we get? And that's equal to, so let me punch my calculator. I have about 0.9832 plus 0.9802 divided by 2, and that's about 0.9817. All right, so this value here is about 0.9817. All right, so I have this. So with this now, I have successfully got the value for the mean of each of them. All right, so I have this. Now, this question here says, assuming the true value for density of water is 1.00 gram per milliliter, calculate your percentage error. Now, how do we find percentage error? Now, recall that percentage error, that's this percentage error, that the formula is equal to true value. So true value minus observed value all over, so all over true value times 100%. So multiplied by 100%. And that's equal to, so my task would be, they said, let's assume that the true value is 1.00. So it becomes 1 or 1.00. That's true value minus the observed value is simply the density of water as I got in my calculation. That's minus. From my calculation here, you can see that the density of water was got as 0.9817. So that becomes my, this one here, that becomes my observed value. That's about 0.9817 divided by the true value, which is what there, 1 or 1.00 times 100%. All right, let's solve this. So that's equal to, so let me use my calculator to punch the numerator. So 1 minus 0.9817, I have about, this gives me about 0 point, so I have about 0.0183. I have this divided by my denominator, which is 1.00 or 1.0. That's 1.00 times 100%. So solving further, it becomes equal to, so the numerator 0.0183 divided by 1 should give you about 0.0183. All right, so if I divide these two here, this and this one, I should have 0.0183 times 100%. So this is equal to, if I multiply by 100, I have about 1.8. That's about 1.83%. All right. So hence the percentage error is simply equal to 1.83%. So this is how we answer this question. So we look at the next one there, which is how to find for length, right? Let's look at the next one there for length. All right, so let's take the third and final one here. Now this is on length. The iPad says obtain a centimeter rule, a small ruler would do, and measure the length and diameter of the test tube provided. Now the length of the test tube, from my own measurement there, I got the length of the test tube as 14.5 centimeters. So length of the test tube is 14.5 centimeters from my own measurement. Also, the diameter of the test tube, I got it as 1.5 centimeters. All right. So this becomes the length of the test tube and the diameter of the test tube. Please, if you got something else, you don't have to change your values. Just work with whatever you got during your own experiment. All right, moving on. It says, using the meter rule, measure accurately the length of this page of your book. So when I measured using a meter rule, I got mine as 0.271 meters. I have this. Now I'm still asked to find the length of this book, but this time in centimeters. As you can see here, it's in centimeters and not in meters. So what do? I would have to convert this value, this one here, convert this value here from meters to centimeters, and I'll do that by multiplying by 100. So if I multiply 0.271 by 100, that gives you about 27.1. But then trying to maintain the number of decimal places, which was 1, 2, 3. So I'll try to maintain 3 decimal places as the first one. So I'll just have to add 0, 0, and that's all. All right, so this is the length of the book in centimeters. So moving on, the III says Measure the diameter of the graduated measuring cylinder and the height from the bottom inside to the topmost graduation. All right. When I did mine, the height was about 9.70. I had my height as 9.70 centimeter, and the diameter I got was about 1.90 centimeter. So I have this. Okay, so next up says calculate the volume of the cylinder. Hint, we're hinted that the volume is equal to, or the formula to find the volume of the cylinder is 3.14 r squared h. Now what's r? They said where r is equal to radius, and the radius is equal to half times diameter, and then they said h means height. So we have this. So let's find volume. Let's find volume using this formula. So if you have to find volume using this formula, what do we do? My first task is to find radius. So we said radius r is equal to half times diameter, and that's equal to half into, what's the diameter here? From here, you can see that diameter is about 1.90 cm. So I'll simply take half of 1.90, and if I punch that, my value is about 0.95. So I have 0.95, of course, in centimeter as my radius. So I've gotten the value of the radius. From this now I can find volume. So how do I find volume? They said volume, let me just write it here. Said volume V is equal to 3.14 into r squared. R is 0.95, so it becomes 0.95, that's r squared, into h. H is height, which is this value here. The height is about 9.70, so times 9.70. All right, multiply this. Let's see the value. So I'll get my calculator and punch 3.14 multiplied by 0.95, which is the radius, all squared, then multiplied by 9.70. My value here is about 27 points. So I have about 27.49 as my result. 0.49. The volume obviously is in cm cube. So I have 27.49 cm cube as my answer. All right, proceeding. So I found the volume here as 27.49%. Now, the next one says, what is the volume marked on the cylinder? So if I look at the cylinder there, on the cylinder, what I see there is about 25 milliliter. I have this. So this is 25 milliliter on the cylinder. Now it says, assume this is correct. What is your percentage error? If your result is more than 10% difference, remeasure and recalculate. So my first task is to find percentage error and see if it is more than 10%. So the percentage error, as we know, is equal to true value minus observed value all over, so this all over true value of course multiplied by 100%. So multiplied by 100%. If I do this now, what do you observe? This is equal to, now the true value will be equal to the value or the volume as marked on the cylinder, which is about 25 milliliter. So I have 25 milliliter minus the observed value would be the volume as I calculated, which is about 27.49. So minus 27.49 all over true value, which we got as 25, times 100%. So I have this. All right, so let's get this done. What do you get here? This is equal to, so if I do 25 minus 27.49, 25 minus 27.49, I have my value here as negative 2, that's minus 2. I have about minus 2.49 divided by 25. So all over 25 times 100%. Now looking at this, I'll see that I'll have a negative value as my error. And usually errors are not a negative value. So in a case where you would have a negative value as error, what do? You now take what is called the absolute value. So absolute value is just this. This is how you put absolute value, by the way. This. So you put this here. This means absolute value. I'll put this here again too. And I'm saying this means absolute value, right? Put this here. That's absolute value of this. Absolute value of this. Now, what absolute value actually means is that even if I get a negative, use the positive of it. That's all. So if I punch minus 2.49 divided by 25, I would get about minus 0.0996. This is my value if I punch this. Of course, since it's absolute value, I'll just put this way. Excuse me. I'll put this way and then this way. All right. So times 100%, and that's equal to, so if I take absolute value of my negative, I'll have positive. So it becomes 0.0996 times 100%, and that's equal to, so multiply this by 100, it gives you about 9.96%. So the idea of using absolute value is to make sure that my error is not negative, it's just positive. All right, so there's no big deal there. All right, so if I look back into this, the instruction was this. It said if your result is more than 10%, if it's more than 10% difference, remeasure and recalculate. So that means if I do my error and it's more than 10%, I would have to redo the experiment. But then if I look at this, my error is about just 9.96. It's close to 10, but then it's not more than 10. So that means, yeah, this is still acceptable. So this is how we solve, or this is the solution for the experiment 2 of the chemistry practical manual. If you enjoyed this class, make sure you like this video, subscribe to this channel for more content, and hit the bell icon so that you get notified whenever I upload a new content. Also, make sure you share this video to your friends so that they can also learn. All right, so goodbye and see you in the next class.